morning. Morning, Mr. Lishan is here. And we are, if I'm not mistaken, this is our last lesson of calculus. Quite a long one, but after that we're done. Okay, we'll probably have one more lesson of just practicing some questions, and then we're moving on. So this is another application. Already last lesson we did a lesson on using the derivative to solve real-world problems. And one of the problems that we often try and solve is a minimum maximum problem. Okay, in the more fancy way, we sometimes call it optimization problems. Okay, so we're going to start. I said real-world problem, but we actually start with not real world. We just start with a function. Okay, so I've got a function minus x squared plus 4x plus 10. What kind of graph does this thing show us?
It's a negative graph.
What is a negative parabola? When you say okay, so it's a sad face. Okay, negative. Okay, so you mean the a is negative. Yeah, it's going to be a parabola. Okay, so obviously a parabola have a maximum, and we're going to try and find the maximum of that parabola. We've done these things last year, even before we learned about calculus. Do you remember how we did that? How did we find the maximum? What did we use? Okay, so interesting you're saying. So yeah, we had the formula. So x, what do we call it? Turning point. So xtp was minus what? Minus b over 2a, where the general formula, I'm going to write it down here, if you remember, was f of x equal ax squared plus bx plus c. Okay, I wasn't going to get into that, but since you mentioned that early, why not? Okay, so we just did minus b over 2a. Okay, so you know what, let's just do it the way we did it before. Okay, so we're going to find, well, that's not really going to give us the maximum. That's just going to give us the x value that will give you the maximum, you know?
Yeah.
Once you know what that is, then you can sub it in f, and that's going to be your maximum, right? So let's try and do it. Might as well do it grade 11 style. So the turning point, the value of x in the turning point will be minus b over 2a. Okay, what is b? 4. So it's going to be minus 4 over? Negative 2, because minus 1 times 2. So we're getting x is equal to 2. And then if we want to know the maximum of the value, okay, so f, yeah, exactly, we're going to substitute 2, we're going to minus 2, okay, so it's minus 2 squared, but we're squaring first the 2 and then minusing, plus 4 times 2 plus 10, which is equal to 8, 4, 14, I think? Yeah. Is that right?
Sounds about right.
Yeah. Okay, so that's how we used to solve it in grade 11. Now we can do it in a whole different way. I mean, look, if you remember this bit, then great. But you'll see that sometimes this is not going to help you. I'll say in a second. But let's do it in a different way. If I know that this is the graph, okay, I'll draw the graph again. So the graph is somewhere like this. How can I find the maximum value? What happens to the curve here? What do we always do in calculus, guys? You find the derivative. What is the derivative here? 0. So what we can do is find the derivative. Let's find the derivative. What's the derivative? Minus 2x plus 4. And then we say, okay, that is the derivative. That's going to be a mark in the case. Okay? You find the derivative, you go a mark. And then what do we do to find that turning point? What do we have to do? This is equal to 0. So we need to solve that. And then you can easily see that you have 2x equals 4, x equals 2. The same thing as here. And you see it? Okay, and then we can again substitute 2. I've done it already. I get 14. Okay? So we've learned, I'm teaching you another way of doing it. You don't even need to remember this thing. All you got to do is find the derivative, make it equal to 0, find the x, find the y. I'll pause for a second. Alright, so interesting thing I've learned now from Finn. Actually, if you just insert that function after you chose ax squared plus bx plus c, it can give you the maximum. Great. But you know that obviously in the test, you actually need to show your steps. So maybe using the calculator just helps you. But I'm going to show you in a case in a second where you can't use the calculator. But before I do that, we're in a position right now, guys, to actually prove this formula. And I don't know about you, that's quite exciting to me. So last year I just told you guys, if you want to find the turning point, just do minus b over 2a. But you might have not asked, why, what does that work? Now you can prove it. Okay, so we're going to start with this, okay? This is our function. I want to prove that the x turning point is going to be minus b over 2a. And I'm going to use the same method that I did here. What do I mean? I'm going to first of all find out the derivative. If this is a general quadratic function, what will be the derivative of it? We've done stuff like that. 2ax. You remember, you got to pretend a is not a variable, a is a constant. We've done stuff like that with letters, right? 2ax plus b. Now, if I want to find for the so this is the derivative. That's always about derivative. In turning points, okay, the derivative is equal to 0, right?
Yes.
Therefore, I can write 2ax plus b equal to 0, right? Let's try and solve for x. Hang on, question, yeah? So, we're almost there, guys, okay? How do I solve for x? Okay, how do I solve for x?
Make y equations. Oh.
Well, I'll move the b to the other side, so I'm going to write 2ax equal to minus b, and then what is x equal to?
X minus 2.
Minus b.
Over 2a.
Okay? Yeah, so that's where it's coming from. Guys, this is the exciting moment in maths, where you actually get to prove things, okay? So, let me just cross some stuff, and then I'll kind of do another example so you know what you need to do. Right, so I showed you a recipe how to find the minimum maximum value of x, okay? And, basically the recipe is, and I will write it down in a sec. Well, I'll write it down now. Just hang on. So let me repeat what's the recipe. The first thing to do, we're trying to find the maximum or minimum value. First of all, we calculate the derivative of that whatever function we have. Then we make it equal to 0. Then we solve for xtp. What does that mean? So this is equal to 0 only when we're in the turning point. Okay, so we basically, when we're solving this equation, that's the x value of the turning point. But that's still not the maximum or the minimum. To get the maximum minimum, we need to insert this xtp, not into the derivative, but into the original function. Okay? So we plug it into the original function, and that's the minimum maximum. Okay, now you might say, hang on, sir, this is too complicated. Why can't we just do minus b over 2a? That's just quicker. Yeah, it's not too difficult to remember that. So it's interesting that we actually proved where this minus b over 2a, but you might still say, sir, I just want to use that. I don't want to use all this. Okay, but what if I don't give you a quadratic function? So what they're asking me now to do is find the minimum. Is it minimum or maximum? Actually, in this case, it's the minimum of this function. It's x plus 16 over x minus 2. This is not a quadratic equation. That's not a quadratic function. You can't use minus b over 2a. What is minus b1 minus, what is a? There's no x squared here. It's something completely different. It's a function that we don't even know how to draw. This is an asymptote. This is a hyperbola, right? If you look at that, that's a hyperbola that's been pushed down. And this is some kind of linear. It's a combination of a linear and a hyperbola. I don't know how to do it. I really don't. Okay? So the question is, how do we find the minimum? Also, it tells me for x equals larger than 0, but we'll leave that for a side. So what should I do? How would I find the minimum maximum? I can't use this one, right? So what should I use? The steps. Okay, we know how to do that. What will be and by the way, this function is not f of x, it's a of x. Why? I don't know. We'll see. Okay? So we're going to find the derivative of a. What's the derivative of a?
Derivative of a is going to be
1. The first term is 1.
1. Yeah.
Now, what's the derivative of 16 over x? That's a little bit difficult.
Minus 16.
Yes, you're right. But let me just, for
X
those
minus
who need some help, we're going to write, how do we do that? We turn it Russian, right? So it's 16 times x to the power minus 1. Okay, I'm still looking for x larger than 0. Okay, so now we can do it. The first one is 1. The second one is going to be what? Minus 16 x to the power
Minus 2.
minus 2, and anything else? No, the minus 2 goes away. Now let's rewrite it in a slightly nicer way. Okay, 1 minus, how do I do it? 16 over x squared. And what do I, so the first step I've done, find f prime. The second step I need to say this is equal to 0. That's how I can solve for x. That's going to give me the turning point. Okay? Now, look, this is a little bit tricky. How do I solve such a thing? Let me pause here. How do I solve such a thing? Okay, so there's a couple of ways. I'll go with what Eugene and Finn said. Let's move. Basically, you don't even need to move it to the other side. Just time everything by x squared. Right? So we're going to have x squared minus 16 equal to 0. Right? I'm just timing everything by x squared. And now, Oli, what do we do? Difference over square.
X equals 4.
X plus 4, x minus 4. Now, hang on. Yeah, x equal 4 is one solution, but there's another solution. X equal minus 4. But why should I cancel it? You're right, I should cancel it.
Because it makes it.
Remember I said in the beginning, they're also asking us to just consider x larger than 0. You'll see why they do that later on, because we still haven't got into the real world problems, okay? So I'm ignoring it. Now, pay attention guys, in the test, you can't, if you don't have it, if you just have x equal 4, you will lose a mark. You still need to write x equal minus 4 and then cancel it. Say not applicable. You know, maybe don't cross it too much because they won't even see it. Just maybe write not applicable. Okay? So just circle that. Alright, are we done? Is this the maximum? Or minimum? How do I find what's the next step? Sum. Should I sub it here? Where should I sub it? Original. Okay? So the minimum value of A, okay, I'll write it A minimum is equal to 4 plus 16 over 4 minus 2. That's, if I'm not mistaken, 6. Okay? And that's your answer. Let's just check. Brilliant. Okay, guys, so now we are actually moving to what I call real world problems. Okay? So for now we found the maximum minimum for some kind of random function that we don't even know what they're about. It was just a mathematical thing. Now we're going to use it to solve real problems. Okay? And this is something actually that you could, that could be a farmer problem. Okay? So we've got a garden, say a veggie garden. And I've got a fence length of 100 meters. So in other words, I know that I have enough material for a fence which has a length of 100 meters, and I want to know what's the maximum area that I can enclose. What will be the maximum area?
50 times.
Good. Okay. So not exactly, but I know you're going to go to the right answer. But let me just show you, go over again the recipe that we have, and then see what we're missing. So I told you the first bit is to find the derivative of f. Then make it equal to 0. Solve for x, find in f of x. What am I missing now? Why can't I find the derivative of f, the derivative of the function? I don't have a function. I don't have a function. So I'm going to have to add a step 0, which is find function. Find f. Okay, and actually guys, in these questions, that's the hardest bit. The rest is easy. It's to find the function that is difficult, and that's what we're going to spend most of this lesson. Okay, but I'm also going to tell you something about exam technique later about it. So imagine, we've got this little rectangle, okay, and we know the perimeter is 100. What will be the maximum area? Now, JD already said something, and I'll ask that question. What should be the length of each one of these things?
25. Is it a square?
It should be a square, right? You're kind of guessing that to get the maximum area, if the perimeter is 100, then I shouldn't really have a square. That means it's 25 each, not 50. But that's what you meant, isn't it? You knew that it's going to be a square. Okay? Why? I don't know. But what else can that be, really? If it should be a rectangle this way, why? Why shouldn't it be a rectangle that way? So it kind of makes sense that it's going to be a square. But now we're going to prove that it's going to be a square. And the way to do it is we're going to say, okay, if this is, let's call this x and let's call this y.
So it's going to be a rhombus.
Okay, so now they told us it's definitely a rectangle. So in other words, the angles here are 90. So it's either a rectangle or a square. But what you're telling me, I will make a guess. I might be wrong, but I still think the square root can maximize the area. I might be wrong, but I'm just guessing. Okay. Anyway, so we're gonna call that x. We're gonna call that y. What we're doing. value in step 0 is trying to find the function of f. What is the function of f? Is going to be the area. So my aim is to find what is the area as a function of x. But I've got to do a few steps first of all. Carry on from here, guys. I don't know if this is the whole video, but so I'm just going to carry on. Right, so Sarah, yes, what will be the value of the function?
625. X times y.
X times y. What do you mean 600? You don't know any numbers. What numbers do you came up with here? Okay? What is the area? How do I calculate area? It's x times y. But the problem is, I want the function of x. I want f of x. I don't want y here. Why do I have that y? Because I don't know it. So I want to eliminate that y. Okay. To eliminate that y, we're going to use some extra bit of information that I've got here. So that perimeter, 100, what does it equal in terms of x and y?
2x plus
2x plus 2y. So you see, I'm always going to get an extra clue in the question saying, I don't know if this thing is working. Anyway, so I always get an extra information here that ties in, relate x and y. And now I'm going to be able to find what y is. I want to get rid of that y. I'm doing what do you call it? Substitution. Yeah, it's like simultaneous equation, but I'm using substitution. So I want to find what y is equal. How would I do it? I'm going to say 2y equal 100 minus 2x. Whoops, I've got a 0 here. 100 minus 2x. I just move the 2x to the other side. And that means that y is equal to 50 minus x, just divided by 2. Are we happy so far? Okay. Now I can plug that in here. So I can find that the value of the area is going to be x times 50 minus x. Now I really should write it down in a proper way. So I'm going to write, I'll write down here. I'm going to write a as a function of x is 50x minus x squared. And now I achieve step 0. Okay, I find a function of the area as a function of x. Okay, I'll just pause here to see if you guys are right. Okay, the rest of the stuff, once we find step 0, we find the function, the rest of the stuff is easy. Okay, I can find the derivative. Okay, what will be the derivative? Stand here. How much? Derivative of this, right? 50 minus 2x. And I gotta say that 50 minus 2x equal to 0. We can solve it without thinking. X equal 25. Okay, which is what we imagined, right? We knew there's going to be a square, the length of each one. Okay, so actually, Finn did say some good answer before that. What will be the maximum area? If I know this is 25, then okay, I need to find what y is, right? I need to find.
You put 25 into the original.
Yeah, I don't even need to know what y is, but let's just find out. What is y? This is 25, what is y? Well, I can use this one, isn't it?
Yeah.
Which is 25.
Yeah.
But I don't even need to know it because I'm looking at my function and this is terrible. Okay.
So this is connected to a laptop.
Yeah, but I said allow, just allow. Once is enough, no? Or is it maybe disconnected and connected? Okay, so I'm going to plug in the 25 here. So 50 times 25 minus 25 squared, and what we'll get is 625. How do I know I get 625? Because I also know that y is 25, and 25 times 25 is 625, which Finn told us a while back. Okay? Right. Before we move on to another example, let me just say a word, as I said, about exam technique. As I told you already, the hardest step here is finding the function. You see how this whole thing took me to find a function? And that's the way you really have to think. The rest is like working like a robot. Find the derivative, make it equal to 0, find x, plug in. Okay? This is the hard thing. Now, why are these questions difficult in a test? Because you don't know how to do the first step.
Yeah.
And then everything else collapses. So examiners can have two options. One option, they will say, and this is, if I write the test, I will do it. I say, show that the area as a function of x is 50x minus x squared. And then all you need to do is somehow hopefully get there, but you might lose these marks. And then in part B, I would say, use this area to solve. And so even if you didn't do that, at least you've got that. And then you can carry on. Does that make sense? But sometime no. Sometime you won't have a show that question. It's just going to be a straight on question. 8 marks or even maybe 10 marks, I don't know. Calculate the maximum area. What do you do then? And you have no idea how to find out. What do you do then? I'm asking you. I'll just pause. Yeah, you're absolutely right, Finn. If you got a question, calculate the maximum area, and you don't know how to get from here to here, just make up a function. Say a as a function of x is 20x. Well, don't make up such a difficult one. So 20x plus x cubed. Or maybe x squared. Not too difficult, okay? Just make it up. Make it up. Okay, you will lose 4 marks here. You will. But then you carry on. You find the first derivative, you make it equal to 0, and you will get all these marks because you carried on right. Okay, this is really, really important because I'm telling you, all these questions, this is the hard bit. The rest is easy. So if you don't know, just make up a function. You will lose a bunch of marks here, but then carry on. Right, let's do some more examples. Guys, so we're moving on to a slightly more complicated question, a 3D question as you already commented. And yeah, so I'll read it. A box with a square base is to be made to contain a volume of 108 centimeter cubed. So they tell us the volume. The box must be open at the top. Let the base length be x and the height h. Show that the total surface area of the box is given by this a of x. So this is the type of question where I told you where they feel a bit sorry for you and they don't ask you to come up with find out the function that tells you or they didn't ask you just to straight away find the maximum area. They just show that the surface area is equal to x squared plus 432 over x. Okay? So if you're stuck in A, if you can't do A, then don't worry about it. Try, fiddle a little bit, but if you can't, just move on to B, because B is going to be just find the maximum surface area. Okay. Right. So surface area. We need to remember about surface area. How do we calculate the surface area? It's basically the area of these 1, 2, 3, 4 rectangles. The bottom. Do I need to add the top? No, because they told me that the top must be open. So the box is open here, so we don't calculate the area of that. Okay? Alright, so that's actually not a very difficult question. Okay? What is going to be the surface area? It's going to be this area. What is the area of this?
X squared.
It's x squared. And what's going to be the area of these 4 triangles? 4 rectangles.
4hx.
So 4hx. Okay.
Wait,
But what is the problem?
Is h the height?
Yes, h is the height. What is the problem? That's the problem, h. I don't know what the h is and I don't want h here. I don't have any h here. So I need to write h in terms of x. I'm looking for another clue. What's the other clue?
First.
The volume is 108. So I need to find out what is that 108 equal. What is the volume? How do I calculate the volume of a box?
It's length times breadth times height.
So it's going to be h times x squared, right? H times x squared.
Yeah. Yes.
Okay? And that can help me find the h.
Yeah.
Okay? H equal 108 divided by x squared. You see this? Yeah.
Right.
Okay.
How do you put that into the
And now I'm going to plug that in, that h,
to the surface
instead
area?
of this.
Yeah.
So I'm going to rewrite that a of x equal x squared plus 4 times 108 divided by x squared. That's my h. But I still need to time it by x. Okay? So in other words, a of x equal x squared, and I guess 4 times 108 is 432. X divided by x squared is x. Okay? I'll just pause here. So that's part A. We've done it. Without asking what part B, what do you reckon part B is? What are they going to ask you now?
What you calculate for x?
Find, so
the maximum.
find the maximum area. Find the maximum area. So we want to find the maximum area. So then we done step 0. Okay? Now we're going to find the derivative. Okay? What's going to be the derivative? I'm going to just do it quickly. I know you can do it. It's 2x minus 432 divided by x squared. I just skipped the Russian stick. But you know how to do it. I know you know how to do it. And the next, at the same time, I'm gonna say that's equal to 0. So I'm gonna have 2x cubed equal 432. In other words, x cubed equal to, what is it, 216. And that means x equal, I'm just gonna copy from these dudes. X equal to 260. Yeah, done that. X equals 6. Okay, plugging it in the original function here. So that means the A max or minimum, whatever it is 6 squared plus 432 divided by 6. And these dudes say I'm getting 108. No. Actually, hang on. They didn't actually ask. They didn't actually ask what's the maximum area. Okay. They asked what's the dimension of the box. So here, let's do that because we haven't done. What's going to be the dimension of the box? Yeah.
Can I quickly ask something about
Let me just pause.
area?
Yeah. Next step, dimension. Eugene, what is dimension? Dimension is basically the length, breadth, and width.
So like
Okay?
x by.
So x is equal to 6. I know this is now 6. I know this is 6. That's the dimension, the length of and width. How would I find h?
You
How do I-
substitute it where h equals 108 x squared.
Okay? So to find h, I'm going to say 108 divided by 36, which these guys say is 3. So I've got x equals 6, h equals 3. That's my final solution for the dimension. Okay? And then the last question is to find the minimum surface area. I've kind of written it. I'm not going to write it again. To find the minimum area, you just plug in the 6 into this equation. You put 6 squared plus 432 over 6, and they got 108. Okay?
Is that just a coincidence?
It's a coincidence. Not exactly. It's the same reason why the rectangle with the smallest or maximum or smallest area was the square. It's the same thing. Here is going to be a pure box. So they're all going to, no, actually, no, it is a coincidence. It is a coincidence. Forget about it. Please. Right, let's pause. We'll stop here. We'll carry on another day. Cheerios.